Welcome everyone to this first research webinar hosted by Egg Farmers of Canada. We have people from coast to coast joining us today, and we're so delighted you can all be with us. My name is Karen Summerfield, and I am the Research and Knowledge Mobilization Officer at Egg Farmers of Canada, and I'll be facilitating today's webinar with Dr. Tina Widowski. We're going to jump to Dr. Widowski's presentation very soon, but first I wanted to note a few features of the webinar. Now, at the top of your screen, you'll see several icons. There's a chat bubble at the top, which is the second icon from the left. And if you have any questions for our presenters throughout the webinar, please type in your questions and our speakers will be able to address these at the end of the presentations. Also, if you're having any technical difficulties, please let us know using the chat box as well, and our technical folk will be happy to assist you. Our speakers today include Dr. Tina Widowski from the University of Guelph, who will be speaking to us about pullet rearing and bone health. Following Tina's presentation, we'll hear from Leanne Cooley, who works at Grey Ridge Farms and also sits on EFC's research committee. She will talk about what this research means for us at the farm level. We'll have time for questions and answers at the end, and we'll wrap up in an hour by 1 p.m. EST. To kick things off, I'd like to introduce Dr. Tina Widowski. Tina holds the EFC Research Chair in Poultry Welfare at the University of Guelph, and she is also a professor there in the Department of Animal Biosciences. Her research has explored hen behavior, welfare, and housing, and she recently chaired the committee for the development of the codes of practice for laying hens. We're very excited that she's here to present some of her latest research on pullet rearing and bone health. So Tina, feel free to take it away.
Thank you, Karen. Hello, everybody. I'm delighted that you are here today to listen to me share some of my recent findings out of our lab. I don't see, okay, there we go. Sorry, I'm getting my technology set up. Okay, so traditionally there's been quite a lot of research that's been done on the laying hen and housing systems for laying hens, but typically the pullet stage and the rearing stage of laying hens has been not very well researched. And in this whole new age of new and alternative housing systems for laying hens, and particularly non-cage systems, the pullet and research into the pullet becomes much more important. And my slides are not advancing.
You're pushing it wrong.
No, I did hit that one, but it wasn't going. Okay, thank you. Okay, so we know that the early experience of chicks and pullets have lifelong effects on the behavior, health, and welfare of the laying hen, and that we're learning more about what chicks need, particularly when they're destined for housing in non-cage and aviary systems. It's well established, and for those of you who have experience with aviaries, you know that hens housed in complex aviaries must be reared in very complex environments. And if without that very important early experience, those hens won't do well. There are several benefits for rearing pullets in a complex aviary and enriched systems. And one of those is the learning that they have to do early in their lives. Pullets and chicks and pullets learn to perch, and there's actually a sensitive period for learning to perch, sort of like when your dog has to be socialized during a specific period of its life. If you miss that critical or sensitive period for learning, the pullet will never do as well. She may make up for it to some degree, but not completely. We also know that in learning to perch, there are strain differences in motivation to perch and their development over time. A recent study out of my lab looked at the development of perching behavior in 3 strains of pullets. And in this case, we had the pullets in furnished rearing cages. And these are the combi cages, like the one that you see here, where there are several different layers or levels of perches in those cages. We compared just the development of perching behavior in these cages with some of the heritage stock that we have in our research station. And these were Columbia Rocks, Rhode Island Reds, and white leghorn birds. And shown here on this graph is the percentage of chicks and pullets that were perching, and this is their age shown at the bottom. The top graph is daytime perching, and the bottom is nighttime perching. And as you the line right here is when cages were cages were split, and the birds were moved from 100 birds per cage to 50. And as you can see, the Columbia rocks perched significantly more than both the Rhode Island Reds and the white leghorns. The white leghorns were in between. As you know, the brown birds love the floor, and typical of that, we see that the Rhode Island Reds perch significantly less. So you can see that perching develops over time, and there's significant strain differences in their learning to perch. Okay, so please advance the slide. Thank you. Another advantage to early experience and being reared in an enriched environment or rearing aviary is that birds have to learn to use three-dimensional space. They have to learn to solve problems, and they also become less fearful. We know that please advance the slide, thank you. Fearfulness in non-cage systems and aviary systems is a problem, particularly because piling and smothering can be a source of mortality. And so it's important that the birds have a good relationship with humans, if you would. And we can accomplish this by spending more time with the birds during that early part of their life. This is not a study out of my lab, but one that I thought would be important that fits well into this webinar, is that a study that was done in Austria showed that even 15 minutes a day of extra walking, talking, feeding, and touching birds reduced their fear of humans, their avoidance distance, and increased the number of birds staying near the human. And this only took 2 weeks of extra handling. So increased experience with interacting with humans, walking the barns is another important part of that rearing experience for the pullets. So in addition to the behavioral effects, there are physical effects on the birds as well. The pullets have to develop complex motor skills in order to be able to negotiate complex ramps and ladders and perch systems, and they also grow stronger bones and muscles, which allows them to be healthier and be able to transition to these non-cage systems much better. So in this new age of housing systems for laying hens, we need a new age laying hen. And so both her mind and her body have to be very well prepared for the laying hen house. Now, one area that has been a problem that is particularly important in the long-term health and well-being laying hen is her skeletal system. And we know that osteoporosis and broken bones are a problem in the modern laying hen. And this is an area we've been exploring quite a bit in my lab, particularly in terms of early experience. Okay, I've got a question for you, but I guess you won't be able to answer me. You can go ahead and shout it out, but I probably won't be able to hear you. How many grams of calcium are in the average eggshell? The answer is approximately 2.5 grams. 2.5 grams of calcium, multiply that by 330 eggs that the average laying hen would lay in her life. That's 825 grams, or half of her body weight in calcium going into those eggshells over her life. And consequently, the selection for high egg production and the need for calcium going into those eggshells causes a problem of osteoporosis. We know that it's exacerbated by a lack of load-bearing exercise. So early problems with osteoporosis were thought to be a consequence of hens being kept in conventional cages where they didn't get any exercise. Now, that lack of exercise in the cage does, in fact, make the osteoporosis worse, but even still, we have hens who get exercise and alternative systems Their bones are stronger, but not quite strong enough. So in any kind of system that the hen is housed in, be careful with her. She's very fragile, and particularly at the end of lay. Now, one area that's been drawing a lot of attention on the research scene is the problem with keel bone fractures. And this is related to the problem with skeletal health and osteoporosis in the modern laying hen. Now, the keel that you see here, that's the sternum of the bird. And this is the bone and site for major muscle attachment for the wings. We've been finding that in all hens, depending on depending on housing system, the incidence rate of keel bone fractures range from 5 to over 85%. This means that in some flocks, 85% of hens will experience a fracture to this keel, and we know it's painful. And because, first of all, it's involved in wing flapping or any type of movement with her wings, but also because of the respiratory system of birds, the keel is moved during breathing. So this constitutes a pretty significant welfare issue for the laying hen. We know that in non-cage systems that injuries from falls and collisions, so design of the system is important in managing or reducing this problem. So we're trying to tackle some of the causes of this, but these do occur in every type of housing system, so we need to still figure quite out about that. But just to give you an idea of the prevalence of keel bone fractures, and this is Canadian data, some of the first. This was a study done by in my lab with Mike Petrick. Many of you may know Mike. This was a longitudinal study. We did this in commercial barns. Some of you may have been involved in this. We went into the barns at 20, 35, 50, and 65 weeks, and this was both in conventional cages and cage-free housing. These would have been mostly floor barns at this time. You can see the percentages of fractures were significantly higher in these non-cage systems than they were in the cage systems. So keel fractures is a problem that we need to reduce and try and come up with ways to manage it within various systems. Then remember I said that the design of systems are important. Here you can see there's plenty of opportunities for falls and collisions in this kind of a system, which could lead to a keel bone fracture. Hens have to be able to negotiate their systems, and this is why strong bones and muscles are important. So we see that keel bone fractures are, by research, a lot of research has indicated that they are most prevalent in aviary type systems. So here is data from a variety of different sources, different studies that have tracked keel bone fractures over time, and we can see that the highest levels are in these aviary systems. So what can we do to reduce these fractures? One way is in the design of the layer aviary. You can see in this picture there is a ladder or a ramp, a wire ramp for the hens, and we know that research in Europe has shown that the use of ramps and ladders significantly reduce the number of keel bone fractures in aviary systems. But what other ways can we tackle this problem? One is by reducing osteoporosis and broken bones through developmental aspects. We've tried nutritional strategies. We know that there's limited absorption for calcium. A hen can take in but not get her complete nutritional requirements for calcium. We know that genetically there's a high production is generally associated with poor bone quality, so there's a trade-off there. So we can use genetics to tackle it, but this may reduce egg production rates. Exercise is another area that we're currently exploring now. And as I mentioned, we know that just like in osteoporotic women, load-bearing exercise is very important for maintaining strong and healthy bones. And this is true for the laying hen as well as it is in humans. In humans, there's also a significant amount of research addressing osteoporosis as a pediatric disease and the importance of exercise in children, and particularly in preteens, on osteoporosis later in life, because we know that increasing peak bone mass during development reduces the problems with osteoporosis. So the development of bones in the skeletal system in birds is a little bit different than that in humans. And shown here is the structural bones of a bird. These develop while she's young, before she reaches sexual maturity. There's cortical bone, which is the outside, gives structure to the bone and strength to it, as well as this what's called trabecular bone, which is sort of a system of struts, which also lends structure and strength to the bone. Now, these types of bones develop while the pullet is early in her development, while she's growing, and before she reaches sexual maturity. Birds have another type of bone that mammals don't, called medullary bone, and this actually serves as a reservoir for calcium when they're laying eggs. When a hen reaches sexual maturity and her hormones change to support egg laying, the bone development switches from the structural type of bones to medullary bone. And what you can see here is that, so this is at 16 weeks, a hen has a pullet would have quite a bit of structural bone. As her hormones change, she begins laying eggs at about 20 weeks. You can see this medullary bone, which is diffuse and spongy, begins to fill the bone cavities. And by the end of 67 weeks, things have changed considerably, because the cells that use and release calcium for egg laying don't discriminate. They use up structural bone, and the only type of bone that's put on or put back into the bone after sexual maturity is medullary. So this results in a decrease in the amount of cortical and structural bone by the end of lay. Okay, we've just completed a 4-year longitudinal study. My recent PhD student, Teresa Casey Trott, completed this work, looking at how early experience with exercise can influence the development of skeletal health and bone fractures in pullets. So what Teresa did is, we reared pullets in either traditional standard cages, or they were reared in an aviary that allowed for extensive opportunities for exercise from the time that the birds were 1 day of age. Those birds were then, once they reached sexual maturity, they were put either in conventional cages, a large enriched cage, or a smaller 30-bird enriched cage. This larger enriched cage housed 60 birds. Then data was collected on the bones and muscles of the pullets at 16 weeks to see how these different rearing environments affected their muscle and bone development. And then again, the hens were examined at 30, 50, and 70 weeks for keel fractures, and at the final time, their bones measured to look at structural bone area. Here, this shows this is an example of our rearing aviary. There are many different types of rearing aviaries, and this one provides extensive opportunities for exercise, running laps, flapping wings from 1 day of age. So we use this as our example, or as kind of the opportunity for the most extreme intense type of exercise. Pullets, we looked at muscle weights. Bones were measured with QCT by Doug Corver at University of Alberta, and analyzed also keel fractures by palpations. So what we found was pullets, those differences in rearing environments had significant effects on the development of the bones and muscles in those pullets, as you might expect. Both the wing and breast muscles were much heavier, significantly heavier in the aviary reared pullets. And this is likely due to the flying and flapping that those birds can do all throughout their rearing period. Surprisingly and interestingly, the leg muscles were heavier in the cage-reared pullets. So standing in conventional cages is a load-bearing exercise. So the birds develop quite differently in these different environments in terms of their bone and muscle growth. Once those birds were all put into furnished cages or cages at the end of rearing, they continued to grow differently, even though they were in the same environment. So shown here are the body weights of the birds at 30, 50, and 70 weeks of age. Remember, those in blue were reared in an aviary, those in red were reared in a cage, and then everybody was put into furnished cages. So the cage-reared birds started out a bit heavier, but as time went on and everyone was in the same environment, those aviary-reared birds put on significantly more weight over the course of the rearing period. So that early experience with exercise had a big difference on their body development later on. They also had differences in structural bone area. This is an example from the wing bone, for example. This is the area, remember that I showed you in structural bone. We use the computed tomography to determine this. At 16 weeks of age, those aviary reared birds had significantly more area to their structural bone. This is during the pullet phase than those reared in the cage. And this stronger or more bone area continued on throughout the entire life of the birds until this is at 72 weeks of age. There were still significant differences in the wing bone, structural bone area at 72 weeks of age. So we see differences early in the life of the bird, and even after those birds are put in the same environments, that early experience had significant differences until the end of their life. Teresa also found a reduction in fractures when birds were reared in the aviaries. So they had stronger breast muscles, different size and larger keels, and those keels were apparently also stronger since there was a reduction in keel fractures in those birds that were reared in the aviary. You see here, they're significantly lower throughout their ages than the birds that were reared in the conventional housing. Here you can see the end of lay. Those birds that were reared in the cage, 75% of them had keel fractures, whereas in the aviary it was only 50%. So that early exercise is helping to reduce this. It's not completely eradicating it, but it is definitely having a significant effect. So the benefits of aviary rearing, we see increased muscle weights of wing and breast muscles in the pullets. We saw increased structural bone growth in the wings. I didn't show you the data, but this was also for the leg bones as well. And then structural bone benefits were maintained through to the end of lay. So the frame and muscle development was quite different, and this lasted throughout the entire life of the bird. Consequently, we also saw fewer keel bone fractures in these birds. Now, the next steps in our research program, not all rearing systems are, so we want to explore how the different styles and designs. Remember, we talked about critical periods. How does different types of experience before 6 weeks, after 6 weeks, and so on, when birds are let out of the different styles of systems, how does that affect both their behavior and their skeletal health? So just my take-home messages are that aviary rearing has behavioral benefits, and it also has physical benefits on the neuromuscular development and the strength of the birds. Exercise during rearing offers a preventative approach to reducing osteoporosis in laying hens. It increases the peak bone mass and reduces keel fractures. Those benefits to the hen structure during those early days lasted her for her entire life. So remember, the pullet rearing phase is critical to the success of the hen. We need those hens to be smart, calm, and fit when they go into the non-cage system, and particularly an aviary system. And I'll continue to try and work on ways that we can improve the fitness and the behavior of the birds in those systems. Thanks very much to all my supporters, and particularly Ag Farmers of Canada, for helping me get this set up today, and also for supporting my research program. Thanks very much.
Thanks, Tina. Just want to thank you for your presentation. You've given us a lot of food for thought and a lot to think about. Now, before I pass the floor over to Leanne, I just want to remind you, all of our participants, that if you have any questions for Tina or coming out of Leanne's presentation, feel free to use that chat icon that you'll see at the top of your screen, second from the left, and just type your questions in there, and we'll try and make sure we can cover all the questions off at the end of our webinar today. Now I'm going to turn to our next speaker, Ms. Leanne Cooley. Leanne is a poultry scientist with LH Gray & Son Limited and is a certified PAACO poultry auditor. She sits on EFC's research committee, which is responsible for making decisions around EFC's research priorities and funding projects. Leanne is going to talk about the importance of Tina's research and how it can be applied on the farm. Go ahead, Leanne.
Okay, good morning to some of you and good afternoon to the others. I'm pleased to join you all on the call today. And I would just like to preface my few slides here by saying that yes, I'm a poultry scientist and yes, I'm an auditor, but I also consider myself a farmer first and foremost. I'm very involved in farm operations with Bill Gray's farming operations. And there's very few things on the farm that I have not personally done, because I don't think you can speak about something unless you've had a point of experience in dealing with this on farm. I'm very excited by what I see with Dr. Widowski's research, because it's really starting to put some scientific answers to some of the things that we're observing on farm, but it also raises a lot of questions about really our practices on farm, and are we really doing the right thing sometimes? And there's a lot of things I think we need to consider moving forward. One of the key messages for me is that our modern laying hens are really, elite athletes. When we think about what this hen is doing on a day-to-day basis on essentially 100 to 110 grams of feed, especially as we move into these more complex environments, these more athletically challenging environments, we need the hen to continue laying that one good quality grade A egg a day for us, but also she has probably some additional maintenance requirements to allow her to be successful in these environments. And so when we talk about going back to looking at the pullet and thinking about simple versus complex environments, there's a word that a lot of people will be familiar with probably from wild animals, and it's this concept of imprinting. And rightly or wrongly, I think sometimes I apply this when I'm talking about rearing pullets, because we are essentially, as the farmer, and the barn environment of the hen, we're replacing that mothering experience. We are the mother now. And we are trying to teach, we're trying to rear these chicks and pullets, and we're trying to teach them. And the barn environment through whole barn brooding takes on that role of the mother hen. And imprinting really refers to a learning experience that occurs at a particular age or life stage. When we look at these simple rearing systems that many people are trying to work with for rearing pullets that are intended to go into aviary environments, cage-free environments, what we have to think about, what are we teaching the pullets with this whole barn brood? What are we asking them to learn? Well, we're teaching them to sleep on litter. We're teaching them to look for feed at ground level. And there's probably different behavioral patterns and behavioral cueing that develops in these environments compared to more complex. We do offer perhaps elevated water line on terrace, but there isn't a lot of requirement for the birds to elevate unless they're motivated to do so. We don't really have a good way to train our chicks to follow the lighting cues that are very important in aviaries. And observationally, I find that pullets coming out of these systems moving to complex lay environments appear more confused, and ultimately we see a higher percentage of birds being unsuccessful at this transition to the layer barn. And that looks like things picking up more strays off the floor at dim down, having to physically help birds up onto the system, less transitioning between the levels. Experientially, when I observe pullets in the complex rearing systems, even though they are offered the open litter space, a number of these birds are choosing to spend their time relaxing on the terraces. We can see a lot of birds are just resting. They're choosing to hang out on the modules. They're hanging out on the elevated platforms during the day, even though litter is open. So the difference with this to the simple systems really relates to the fact that we start the birds from day of age within the modules. It's not until somewhere between 4 and 7 weeks that the modules are opened up to the floor environment. So this means that we're essentially imprinting the birds in a different way. We're teaching them to sleep on wire. We're trying to promote more nighttime perching. So we're able to use our lighting cues differently. And all of this, I think, has different behavioral cueing to the birds and is changing how they adapt to their environments. Dr. touched on the fact that there are some strain differences, and we can see this very clearly. And what does that mean as a farmer? Sometimes I'm not sure. I have an example for you here where I'm growing currently 2 strains of birds with simultaneously within the exact same barn environment. So we can see that strain X, upon opening up the modules, we have a very high proportion of birds that have already transitioned to using the floor of the barn. Strain Y, although the same age and the doors of the modules were opened at the same time, these birds are choosing to stay within the modules. They're not moving down to the floor. What does this mean for a sensitive learning time? Well, if birds are choosing to stay in the modules during these sensitive early weeks of learning, they're not running up and down these open aisleways. They're not hopping and jumping between modules and climbing ladders. They're choosing to just stay within the modules. So what does that mean for all those great points Dr. Widowski made about bone development, muscle development, learning these skills? Are we accomplishing it? However, just because these birds are choosing to come out doesn't mean they're accomplishing developing these skills either. They may be just choosing to live very easily in and out of the bottom cage. However, we can see there's different behavioral cueing. When strain Y can see strain X birds on the other side of the fence, they're encouraged to come out of the system more readily. What does that actually mean? I'm not sure I can answer that question. Dr. Widowski touched on differences related to bone and muscle development. I certainly find that we have to feed these birds differently. And I have an example of how I might feed a conventional pullet in terms of changing protein, making dietary changes. But I find I have to feed pullets in aviary systems who are getting more exercise very differently, because it's challenging sometimes, particularly to 4 weeks of age, to meet those early body weight targets. But there's problems with feeding surplus protein for too long in terms of risks for necrotic enteritis. So how do we accomplish meeting those target body weights? If birds are here, if they have more muscle development, more bone development, I would expect them to be heavier than the breed targets. So I'm not simply satisfied with being at breed target weight for age on targets that are developed for conventional cage pullets. Muscle and bone weighs more than fat. So we should see different body weights relative to age in systems relating to the amount of exercise pullets are receiving. We know there's a lot of grade A influences on egg size and egg quality. And highlighted in blue are all of the types of areas that influence grade A eggs, but these are very different depending on your type of housing system. So how do we know vaccination can be much more challenging in open systems? Based on body composition, proportion of to lean muscle percentage, we might see differences in onset of maturation. What does that mean for optimum lighting program, light intensities? This is influenced by density, it's influenced by nutrition. So we have a lot of learning to do and how to optimize for these alternative systems, not just in lay, but also in rearing. We can accomplish very good grades, and it makes sense. If we're seeing birds that have more structural bone, it means they have greater reserves for medullary bone. They have just greater bone reserves to take them out into that extended period of lay. And that's a great thing, because we need these birds to maintain fitness. They can come into the layer barns very fit in terms of high levels of muscle, good bone density, but we need to then maintain that for 80 weeks of lay. And we're seeing that based on these cracks and reject profiles, that the hens are doing very well when they're managed appropriately with feed and nutrition. However, I will note that sometimes we will see an increased percentage of grade B eggs particularly in brown, doesn't mean the whites aren't laying them. We just can't see it from the pigmentation irregularities. And this may relate to delayed egg lay while they're looking for that optimum nesting site. So I think the one thing I can emphatically say as a pullet and layer farmer who has been working with these systems now extensively for 6 to 7 years is the pullet really is the foundation. And it's an area for very little economic investment that we can have tremendous influences on the health, fitness, but also grade A return from our layer flocks in lay. So thank you very much.
Thanks, Leanne. Thanks for your presentation. It's been a full half hour, and I'm sure that we've got lots of questions from our participants. So if you have a question for Tina or Leanne, again, please submit your questions using that chat box icon at the top of your screen. It's that second icon from the left. It looks like we've got a question already, so I'll just read it out, and then Tina and Leanne, maybe you can respond. So the first question is, given the increase in stem cell differentiation and proliferation into structural and medullary bone, do you feel the nutritional research, primarily with amino acid profile requirements, is addressing these changes in the avian cellular and physiological development? Tina, do you have any thoughts on that?
I think that we have to, it's a whole new area in determining appropriate ways to feed the birds in these different systems. During both development, there's very little actually that's gone on at the layer stage as well. And as we can see, these are such dramatic differences in the way that the birds develop in the different systems that nutritional research is inadequate right now, and it is there's a huge need for more information in this as we go forward.
I would just like to add a comment that I feel that we do not fully understand, speaking as a poultry nutritionist as well, because I have extensive training and experience in poultry nutrition as well. My observations for the pullet side of things is I don't think we have the amino acid ratios quite right, because I'm finding that if we're lagging behind in growth rate in those early periods, 6 to 8 weeks, I can step down protein and add some supplemental lysine and get very good responses in terms of body weight development and weight gain with some supplemental lysine. So that we know that lysine is a key limiting amino acid for muscle development. So that leads me to believe that formulating pullet feeds based on just crude protein levels for these types of systems with the extensive amount of exercise involved, I'm not sure we have the amino acid composition or ratios correct.
I think I would like to add that I want to point out that during our that experiment where we had the birds reared in the different systems, they were on identical diets so that we were just measuring the effects of environment alone. So the bird's nutrition was not optimized for those different environments. So imagine what we could see in terms of benefits to the birds if their diets were actually optimized for the differential rates of development of different types of tissues in those systems.
Thanks, Tina and Leanne. We have another question that's come in, and it's, have either of you had any experience with the winchable platform systems versus more conventional style of aviaries? And if so, what are your thoughts on them?
The system that we used had winchable platforms. So they actually started out, so as I mentioned, we used a rearing system that in our minds offered the greatest opportunities for exercise from the time the chick was placed in that system. So it's large open areas with where the platform is started on the floor, and then that platform is winched up as the birds grow with the water lines on it, so that they are hopping up to it as they grow. And so our experience with it, that's the one that we used at the research station. So that's really the one speak for that had the benefits that we saw in terms of exercise with the birds.
Yeah, I would like, what I find with I have experience actually running multiple types of the pullet rearing systems on Bill Gray's farm. And what we find is that with the winchable systems and the systems that have the elevated terraces where the water lines are ultimately moved up over top the increasing height of the winchable platforms, or it's moved up onto various levels of the terrace. And the requirement then is for the birds to do more jumping, more elevating to obtain and follow those resources. I find that translates into the layer barn in terms of laying hens that are more athletic, laying hens that are more vertically motivated and are also have developed the suite of behaviors that enables them to make those big jumps and those big hops. What I'm finding a little bit is perhaps the systems for the pullets are transitioning to ease of management for the farmer instead of maybe focusing on behaviorally what we need to optimize the development of the pullet. So the module systems that are more like conventional pullet cages with, you know, an elevated perch over the feed trough or perhaps an internal terrace, they offer an ease of management to the farmer, but they require less athleticism or less vertical navigation by the birds. And particularly some of these can be, the bottom module may only be 8 to 10 inches off the ground. And so birds that are not very motivated can live very easily in and off the floor, only having to move up about 8 inches and still obtain feed and water. So there is some limitation to those module type systems, I find, perhaps in some of that vertical training.
Thanks, Leanne and Tina. As we wait for a few more questions to come in, and again, I'll just encourage all of you, our participants, to use that chat feature to submit your questions. We have a question here at the EFC office, actually, around if you could both sort of comment on what other aspects of pullet rearing you might be exploring to get the best benefit for full-grown layers.
In terms of research questions right now, we've got a lot of questions in terms of density and space allowances. And I have actually EFC-funded research project on right now where we're looking at space allowances, both in conventional rearing systems, because those are going to be around for a bit, but also in some of the alternative systems. How much space do the pullets need as well? Feeder space. When we were working on the code of practice, where we now have a pretty large pullet rearing section in the code of practice, there were so many questions came up with the group. We had to rely on practical experience, which was wonderful because we had such a knowledgeable group sitting at that table. But in terms of research, for informing various aspects of housing and management for pullets, there's still a great deal to be done. So stocking density, perch space, the nutritional aspects, as we mentioned, feeding behavior, locomotion development. My colleague, Andrew Harlander, is looking at the different sort of ramp angles, how birds develop, the different patterns of locomotion that they require in these, like wing activated incline running, when the birds flap their wings when they're going up a ladder to help, how these different types of movements contribute to development, what kind of experience is needed for neuromuscular control, good balance, and those sorts of things are still questions that we're trying to tackle right now. Leanne?
In terms of applied on-farm work that I'm doing to improve the performance at the lay barn, but also uniformity of the pullets. That's a really big factor for me, is uniformity of body weight of the pullets and feathering. Everybody who knows me knows I'm crazy about feathering, and I'm always constantly working at promoting feathering. But the thing I'm probably spending the most time on right now relates to vaccination programs. I'm seeing generally very poor titers on vaccination programs for coming out of alternative systems with a lot of the independent farmers I work with. And that I believe there is a relationship to E. coli associated mortality at the layer barn. I believe there is a three-way combination there relating to dust levels, aerosolized dust levels, E. coli, and particularly bronchitis titers. And so that's something I'm spending a lot of time working on with the farmers that I work with. And then the other area I'm doing a lot of focused work in relates to gut health. Obviously, when we have these higher litter environments, we have potential for more ingestion of fecal matter, potentially dirtier water lines as a result. And so I'm spending a lot of time looking at different ways, but simple ways, cost-effective ways, like going back to using whole grit feeding programs, particle size, some dietary composition things we can do to optimize crop and gizzard development in our pullets, optimize gut health from a pullet, because I'm finding that I'm observing lifelong benefit to making that investment in the pullet stage.
I think one additional area that we need to, the knowledge in the field is accumulating, and so is the research knowledge, is the genetic differences, and does early experience impact the different strains differently? So we were always talking about we need to match the strain to the housing system, but does the early training period alter the bird who's destined for different types of systems as well? Doing better at matching the right bird for the right system and matching the right training for the right bird for the right system is something else we have to learn quite a bit about, I think.
Yeah, thank you both. Again, I'll give people a chance to enter their questions into that chat box. And in the meantime, while we give folks sort of that one more chance, in terms of this project overall, was there anything surprising for both of you, or anything that particularly stood out that you just wanted to kind of reemphasize or bring up, or feel like you needed to speak a little bit more to?
Yes, I think so. In terms of, remember we moved all the birds into different sizes of enriched cages in there. And one of the things that I didn't present on because of time was limiting is to look at whether either the 60 bird cage versus the 30 bird cage had an influence on the birds' skeletons as well. And we did find that in some of the bones, density and strength was actually greater in the large 60 bird cage compared to the 30 bird cage. And I know many people are less comfortable going into a larger furnished cage, but from the standpoint of the potential for exercise for the birds and just the amount of free space in that situation as well, because birds tend to cluster together and then it opens up more space. We found advantages, some advantages in the large cages over the smaller enriched cages in terms of bone strength. And so I think that the birds are getting more exercise in those larger cages. And some of our other work has indicated that there might be advantages in terms of space and behavioral opportunities in those larger cages as well.
Thanks, Tina. Leanne, anything that you wanted to kind of speak a little bit more about, or?
Well, I think one thing that stands out for me really is the research results relating to body composition and the changes in structural and medullary bone composition, because we're dealing with a very highly selected bird, yet we can see that there is still room to optimize the potential of these birds and optimize our feeding programs. And I think that is an area that we can really focus on in the industry, and we really need to be aware of as we're rearing, thousands and millions of pullets, is that what are we choosing to select for our target body weights for age? Are we really optimizing frame development? What should those body weights really be at the different ages if we're truly building the ultimate skeleton and frame and musculature to make these birds be the athletes for that, entire production cycle. So it's exciting for me as a farmer to see the research data that supports why I'm having to feed these birds differently on farm, and why at certain times we may have challenges, hitting what we think the body weight should be.
Thanks, Leanne. It seems like those are all of the questions that have come in. So I'd just like to take this opportunity to say thank you to everyone. This has been a great webinar. I'd like to particularly thank Tina and Leanne for presenting to us today, and to all of you, our participants from across the country, for joining us. We have other webinars coming up over the next few months, and our next one is on June 6th, so next week. We'll be turning to human nutrition for this webinar with a presentation from Dr. Dominic Alexander about the link between egg consumption and reduced risk of stroke. You can find more information about this webinar on EFC's website at eggfarmers.ca. Now, we've also been recording today's session, and we will share the link with you once it is up in case you'd like to share today's presentation with your colleagues. And please contact us if you have any questions. You can email us at cpa@eggs.ca with any questions that you might have. So I'd like to thank you all for joining us, and just wish you a great rest of your day. Thank you.